Yeah. My people that just got their test back, you might want to go on when I was talking through the scoring, etc. If you guys remember from Friday, what are the biggest ranges in the CalcAB? The 5 and the 1. So breaking out of the 1 category is actually really hard in calculus if it doesn't come naturally to you. Breaking out of the 1 category is our first goal. Some of you actually broke out of the 1 into a 2 on the mock AP, and I was really proud of that. Because that already means, okay, you can break out of the 1, and then once you break out of the 1, the point distributions are such that it's like 8, well, depends. The ones for this one were a little bit weird. We'll say 10 points. We'll say 10 to 12 points to get from like a 2 to a 3 to a 4, a 4 to a 5. So if you think about it, if some of you look at your FRQs, you don't have to raise your hand, but if you got at least 1 0 out of 9, 9 points could almost, depending on where you were in the range, could almost, like if you could have gotten 1 more FRQ, you could have had 1 point higher on the exam. It's very possible. Or if you had had 2 FRQs that you had done better on. A lot of you guys missed tons of points on the FRQs that were somewhat unnecessary. Some of you guys didn't put a DX. Some of you guys simplified addition or subtraction or multiplication and made it wrong. Some of you guys had whole concepts that were lacking. Can we have the confidence real quick just to be like, hey, this was either when you took the mock AP or still currently, or when you were doing the LTF, can we have confidence just to shout out, say your name and say, hi, my name is Ms. Dweck and I struggle on, hi, Ms. Dweck, who struggles in, no, it's not like an AA meeting, okay? Just, let's be honest, what is a topic that's hard for you? Go. Midpoint Riemann sums, what else? Volumes and areas. What else? Oh, okay. Tyler agrees. Has anybody else found a weakness on their AP or found a weakness in the LTF packets? Oh, FTC stuff. FTC stuff. An accumulator functional. An accumulator function. Simple math. So true. So true. Ah, you have to fight the urge to simplify. We were talking about this one, right, Sean? This was yours, the accumulator function. Anybody given a graph of a derivative? Given a graph of a derivative? We okay on that, David? We're basically calling out our weaknesses in calculus and owning them and then committing to work together as a class on them. Factoring. No, it's true. Finding zeros, critical points, sometimes you need to. Anybody theorems? Using theorems, if there must be, getting to see whether it's an IVT or an MVT or roles. How about some of you guys justifying?
Yes, description.
Justifying, explaining, FRQ, interpreting, using words. That's hard. Can't just do a sign chart. How many of you guys word problems? When it says rate and you have to figure out, wait, what's going on and what am I supposed to do? Whether it's related rates or whether it's just a word problem with derivatives. Okay, so these are all things that, wait a minute, are in our forevers, are in our when you see you thinks, have questions in the practice exams and the LTF packets. So do we need to stay stuck on them? Does that make sense? What's the entire format of my class? The entire format of my class. All year. You guys know how I teach. How do I teach? Yeah. Learn new stuff. Try it. Find the weaknesses. Work on them. Learn new stuff. Try it. Find the weaknesses. Work on them. Isn't that how I grade homework? Isn't that how I have you guys grade your tests and do corrections? That's my entire format is try it, make mistakes, analyze the mistakes, try again. Right? Okay, so that's what we're doing on the mock AP on LTF number 12. Let's come LTF number 12, related rates. We did a lot of multiple choice questions on Friday. I think these pages really helped you guys. The translating, I think they really helped you guys. It's probably something I should bring in earlier in the year. I did it and I said it, but it wasn't quite as simply delineated as now. And some of you are like, ugh, I'll never get this topic. I remember how hard it was when I first learned it, but please realize you are coming at it from a very different perspective now. You're coming at it from having seen the full, not the full as in like a, grad student in pure mathematics type perspective, but you're coming at it from, we've done the entire course of Calculus 1 of Calculus AB. And so the knowledge, the experience that you're bringing to it now could make a world of difference if you just try. So, related rates. Were there any multiple choice that we weren't able to go over? Things that you got wrong, things that you marked wrong, you didn't get corrections down? Yeah. We did 1 through 9? Perfect. I know we did a lot of them. So are there... Okay. For all the mistakes that you had? Perfect. So those of you guys got on Friday, you can check out for any of the multiple choice. We did a lot of them. We did a lot of multiple choice. Perfect. 1, 3, 5. Oh, yeah, you're right. We did go through all. So now we're going to go ahead and look at the FRQs, if I can get this to actually open. Thank you. There were 2 of them, right? Okay, let's look at the first. As you guys are looking at it, remind me, what was going on in the first FRQ? Okay, so translate the given. Translate the given. Good, the radius of the circle is increasing, so dr dt is equal to centimeters per second. Who's R? Maybe we should like label our picture, huh? Isn't R going to be... Now, we could do that, but it's not in the square. Yeah, what would be the best? Good. And if that's R, what's this? So the entire thing could be the diameter. So 2r could be the diagonal of the square, right? When the side of the square, that would be S, right? When the side of the square is 4 centimeters, what is the area of the circle? They're making us think of area equals side squared. Ah, so area equals? Okay, so they give us that S is equal to. They're making us relate radius with S, which is going to be important in just a second. Sarah. Yeah. Yeah. Exactly. But how? S would be like A, right? And S could be like B. And then what would be your C? So it's asking you to figure that exact thing out, Sarah, and be like S squared plus S squared is equal to 2R squared. Does that make sense? So A squared plus B squared is equal to C squared. And so then we have 2S squared is equal to 4R squared. We could plug in 4 for S, right? So then that leads us to 4 squared is 16. 16 and 2 is 32 equals 4R squared. R squared is equal to 8. R is equal to 2 rad 2. Then we come back and we plug that in. We can say pi times 2 rad 2 squared. Oh yeah, definitely. Definitely. This is like a long answer, right? No, go ahead, you're good. The problem is if you have a squared plus b squared, you wouldn't know that they're both the same side, so you wouldn't know that you can combine like terms. Does that make sense? So you would have needed more clues than you were given. Like if it was a rectangle, it would have been kind of sunk if they only gave us one side. Since it's a square, then I'm golden. So I have root 8 squared. Now to be honest, this is a FRQ that's kind of like building up to the final, like the finale. It's kind of giving you the steps to the related rates problem. Because if they asked a related rates problem, we would have to get R's and S's in the same terms of each other. Oh yeah, they're literally just looking for the geometry in A. Letter B says when the side of the square is 4 centimeters, what is the rate of change in the area? Translate. No, dAdt, thank you. Translate. Rate of change in the area. We want to find dAdt given S is equal to 4 and given dr dt. So can't we take, hey, cool kids, you were rocking this on Friday. How do you take dAdt of this expression? Sorry, ddt. Good. This is going to be 2 pi r times dr dt equal to dA dt. And what are we plugging in? They had us do this problem so that we would have something to plug in for r. Give us s, we would have had to go and find this relationship of Pythagorean theorems. This could have been a multiple choice question, and you would have had to figure out r. You would have had to figure out r in order to be able to plug in. So then we can go ahead and say, oh, since we already figured out the whole Pythagorean theorem thing, since we already figured out when s is 4, r is root 8, then we can plug in 2 pi times root 8 times 0.8. And what would my units be? Centimeters squared per second. Why? Because it's units of area over units of time. So centimeters squared per second. Does that make sense, guys? Okay. Then last but not least, letter C. Uh-oh. I have some trouble. Letter C says, when the radius of the circle is 5 root 2 centimeters. What? What is the rate of change in the, what? Hold on. The rate of change in the shaded area of the region outside the square, but inside the circle. Aren't they talking about this? How can we put an expression for that area? Yeah. When the radius of the circle is 5 root 2 centimeters, what is the rate of change in the shaded area? Outside the square, but inside the circle. Here's the struggle. If I go to take the derivative right now, it's like, I'm good, 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 I'm really, really, really bad. Pause. And letter A, didn't you relate side with radius? What was the relationship with side and radius? It was 2s squared is equal to 4r squared, right? Which we could divide either way. S squared is equal to 2r squared. Couldn't I take d dt of this? You can relate, or I should say you can rate. You can take derivatives of not only this expression, but also earlier expressions. Check it. Now what do I know all of a sudden? You can come back and take the derivative of relationships between data also. Because now all of a sudden, look, I can figure out that 2s ds dt is the same thing as 4r dr dt, and he's the guy that I have. So we came back to our whole little Pythagorean theorem thing. We said we can take the derivative of that guy too. And then we were able to get rid of the ds dt and the s and say, oh, let's just plug in. I think, they changed things up. 5 root 2. So we have 2 pi 5 root 2. What was my dr dt? 0.8? Yeah. And it's increasing, right? Positive. Decreasing. Thanks. And a minus, so I have 4r dr dt. Centimeters squared per, is it second, minute? Second. Box it, done. Don't you dare simplify. Sarah. Right. No, and here's why. There might have been a product rule. There's no divisions. That's why no quotient. But think pi is a number. So it's as though you were taking the derivative of like 5x squared. The 5 would stay, the 2 would come down. So for pi r squared, the 2 comes down, the pi just stays, it's a constant, and then it's r to the 1. If you were to think product rule, which, I mean, it's never, I shouldn't say never, it wastes time. But if your brain sees product rule, you could always do it as long as you realize the following. If I was derivative ddt. Second, d first would be 2r times derivative of pi. If you realize it's a constant, you would say pi is like an x, then you would say 1. So that's where the mistake could happen. So you could do 0. If you can understand that's a constant, product rule to be safe. It adds work, so you might make a mistake. But second d first plus first d second. You end with 2 pi r, I apologize, dr dt. You would end at the same place, but the reason you're doing will result in a mistake that you might make this a 1. You would still have a derivative of 0, just here there would be a 4, so then the 2 would come down and you would have... Does that make sense? Okay. FRQ number 2, because we did the whole thing for 1, right? 1 was weird. That's why I thought we'd just go for it. Sorry, the second one you had to do, which was number 3, right? You don't? Something happened on the copies. Sorry, every now and then. Well, this is a better, I think this is a better problem. They're both not too bad. You just tap the back page if you want. Sean, sorry, here's your multiple choice. And Sarah, here's your multiple choice. You can paperclip it with the rest of the exam. Yeah, go ahead. In the email that I sent, there's your exam that you have right there. And then there's the other exam that was given. So for you, you took yours Saturday, so then the Monday one is in your email. You can either save it to your phone and whip out your phone during class so that you can see the questions and refer to them and you can write it like a practice exam. Corrections were technically what we're working on in class, theoretically today, but we're almost out of time. Doing the other exam is what I intended as far as A. And then we'll kind of just piece together on the corrections. So I'll be like, hey, any mock exam questions? And they'll be like, okay, any practice exam questions? So we're kind of just doing questions all over the place. Because some people are going to come with the Monday questions, being like, well, I have Monday questions. Well, maybe they could be also doing the practice exam from Saturday so that we can have the same questions, and then vice versa. Does that make sense? Austin? Uh-oh. I don't know if I have any other multiple choice. So I had the huge stack. And remember there was the big stack, and I thought I had you get it out of there. You never got it. You never got it out, bud? You can come at the end of the day and check, Austin, but whenever anyone picked up, I had them grab their multiple choice out of the pile. So it might have been that you didn't realize what you grabbed out, but maybe it'll be left over at the end of the day and it got stuck in like a BC thing. But I had a huge pile and I got rid of it all. So yeah, come check in a little bit later. Okay. Letter A says write the formula for the volume of the cone of water in terms of H. You guys have water in the tank, right? They tell us that the tank is 24 feet tall and has a diameter of 20. Guys, we could talk about similar shapes in geometry. It's been a while since we did, but guess what the ratio is always going to be as far as the height and the radius? Radius over height is always going to equal a ratio of 20 over 24, which would be 5 over 6. Because wherever the water falls is going to be a similar shape to the tank itself. And similar shapes have proportional size. Oh, thank you. I did R. Thank you, thank you, thank you. I did R. That should have been D. Thanks, Sean. Which should be 2/6, which should be 1/3, right? Oh, not 10. 5. Hold on, I need to write it. I'm trying to do too much at once. 5/12. There we go. And so the nice thing about this is once you get R over H is equal to 5 over 12, you could say 12R is equal to 5H, which you could say R is equal to 5/12 H. And what do you now have? A relationship between radius and height that you can use. So for instance, in letter A, when it says, write a formula for volume in terms of H, they're like, get R out of there. How do I get R out of there? I had to see the proportionality of the dimensions of the water with the tank. And this can always happen, will always happen whenever the shape of the liquid inside, when it drains, maintains the same figure, in a sense, the same geometric proportions as the tank itself. So whether it's draining out, whether it's coming in, I can go ahead and maintain that proportionality. So therefore, we could go ahead and plug and chug. Now, kiddos, did you have a particular place? I mean, I could go ahead and plug this in. We'd have V equals pi R squared, but instead of R, I plug in the other part. There we go. And that would be a cylinder, but this is a cone like Charlotte was saying up here. So a cylinder, pi R squared H, a cone, cut it in third. I could simplify that, but now I have V and I have H. So what was going on in letter B? At what rate is the height? Find dH dt such that dV dt is equal to 3.4 and H is equal to 2. Yeah. Careful. Look at the wording. Because when it says write the formula for, because you actually said it, you're like for height, but read the problem for. Yeah. But now, where did you get stuck? Because it says for volume. So you're like, okay, V equals, but check it. In terms of. So what they wanted V of H. Instead of F of X, it was V of H. So that means that they didn't want the R. They wanted the R out, and they wanted H in terms of H to be plugged in. Does that kind of make sense? So in letter B, kiddos, you would just take the derivative. I'd probably move all the constants out in front and make life a little bit easier. So you have, what, 25 over 144 times 3 would be 8. That'd be 432. My guys, that did it. 144 times 3. Yeah, 432. Sorry, I thought some of you guys had already solved this. I apologize. And you have dH dt. So then I'll let you guys go ahead and keep looking. You can tell the answer if you want. I think this was probably the key that you were missing, was the proportionality deal, how to relate R and H together. We can go over this FRQ tomorrow if there's anything left over real quick as far as what's going on. Let's do this. Let's do this. Tomorrow, we're going to be specifically looking at the A multiple choices. Now, how many different exams do we have? The one you did already, and done. So I'm going to look at 8 multiple choices, both of them. What would be ideal when you come in tomorrow? To have your mock exam that you took and to have tried the other A's and been like, I have questions on these. Does that sound good? So tomorrow A's on both exams. The next day will be B's, both exams. And then Thursday, Friday will be the FRQ multiple choice. And so for the FRQs at the end of the week, I'm going to go ahead and get the BC projects posted online so that you guys can access the full videos for the FRQ explanations of Saturday mock. They didn't have time to go to. Yeah, basically. Tomorrow A's, we got it? Okay, we have a whole nother minute, but thanks for being, oh, no we don't, just kidding. I can't read my own clock.